welcome to Future Talk. On today's program, we're going to talk about the future of energy and whether it's possible to dispense with fossil fuels altogether and get all of our energy from clean sources such as wind, water, and solar power. My guest says that it is possible. He is Mark Z. Jacobson, Director of the Atmosphere Energy Program at Stanford University and a leading researcher in atmospheric science. Professor Jacobson studies the physical and chemical processes involved in air pollution and looks for ways to integrate clean and renewable energy into the power supply. His computer models of the atmosphere have been used by about 1,000 researchers in the field. His work has served as the scientific basis for proposed climate legislation. He served on an advisory committee to the U.S. Secretary of Energy and has testified several times before the U.S. Congress. Mark, welcome to the program. Good to have you here today.
Thank you very much, Marty. It's good to be here.
Now let's talk a little bit about air pollution. Just how serious a problem is this, and how urgent is it that we start cutting back on fossil fuels?
Yeah, we look at air pollution and climate problems and energy security. And air pollution is one of the 5 leading causes of death worldwide, with 2.5 to 4 million people perishing each year prematurely from air pollution and the complications arising from it. And this is not only devastating to families, and in fact, in developing countries, about 20% of the air pollution mortalities are children under the age of 5 years old. But it costs society on the order of 3 to 7% of the GDP, or the gross domestic product, of individual countries. In the United States, there's still 50 to 100,000 people who die prematurely each year from air pollution. In California, it's about 16,000 per year, and in New York State, for example, it's about 4,000 per year.
It sounds like quite a bit. We have a couple of slides that show air pollution. Can we see the first slide, please? Okay, so this is someplace in Russia, Norilsk, Russia. Is that an average day for this town, or is this the worst day ever? I mean, what's the context for this?
Yeah, if we look in North America and Europe, air pollution has gotten better, but in most of the world, including in Asia, in Russia, Southeast Asia in particular, and lots of parts of Africa, you have really serious air pollution problems. So this would be very typical. But not always. You don't always have air pollution this bad. But just to give you an example, in China, between 800,000 and 1 million people die every year of air pollution. You can have 2 or 3 weeks where the visibility is very bad.
Is air pollution a contributing factor to the deaths or the primary factor in the deaths?
It's both. Well, people die from cardiovascular disease, complications from asthma, respiratory illness, and in the case of children, it's like their immune system is weakened, so they're more likely to die of pneumonia. So if you have a heart attack in polluted air, you're more likely to die of that heart attack than if you have a heart attack in clean air.
We have another slide showing air pollution in India. Can we see that one?
Yeah. So
okay. So what are they burning there? Are they burning coal or gas?
Well, this is most likely a chemical factory where they're producing some products, and they're burning chemicals, and so that's causing the coloration of the air.
Now, will they say, well, we know this is a problem, but we can't afford to clean it up economically? We don't have enough money to generate cleaner energy.
Yeah, that's the excuse many times. But the fact is that the air pollution is causing lots of costs in terms of to the society that are being borne by the entire society, and nobody's paying for those costs except for the families. And even in the U.S., air pollution illness, as I said, it costs 3 to 7% of the GDP, and that's in terms of hospitalization, lost work days, lost school days. We pay higher insurance rates, we pay higher taxes as a result of air pollution mortality, and also what's called morbidity or illness related to air pollution.
Well, let's talk about some of the sources of clean energy. So we're going to talk about sunlight a bit. Is that able to be used on a large scale? Doesn't it take a lot of land area to gather enough sunlight to generate significant amounts of solar electricity?
Not really. So I can give some examples, but solar and wind in particular are 2 ubiquitous energy sources, clean natural energy sources, that are the only 2 energy sources really that you can actually power the entire world many times over with. So for example, there's enough solar energy over land and high solar locations worldwide to power the entire world's energy infrastructure for all purposes about 30 times over.
And I think we have a slide of that. Can we see that slide? Okay, so.
Yeah, this shows the solar resource of the world, and the red indicates where you have higher solar and the blue is lower solar radiation.
It looks like there's more solar over the ocean. Is that true?
Oh yeah, you get a lot of solar over the oceans. It all depends. This is the downward amount of solar radiation. So if you have, sometimes you have areas where you have a lot of reflection of light. So you get, even though you have the same amount getting to the surface, not all of it gets absorbed by the surface.
Now we have a slide that shows some of the uses of solar energy, what a solar array might look like. Can we see that slide?
Yeah. Well, this
okay, I think that's the wrong slide. I think we want to go back and yeah, you almost had that one.
Well, the solar slide, it's going to show.
That's the one. Okay.
Yeah, it's showing two types of solar. One is what's called concentrated solar power, which is the left slide top, and that's where you focus light off of mirrors onto a central tower receiver to heat a fluid, such as what's called a molten nitrate salt. And that salt, it's really nice because it's hot now, and you can store it at night and then you can use it at night to run it by water, to evaporate the water, to run a steam turbine to generate electricity. So the nice thing is then you can actually generate electricity at night with solar power this way. So some of these towers have been put up around the world, mostly in Spain and in California, and they've actually been used to generate electricity 24 hours a day. So this is a way to get rid of the old problem of where solar can only be used during the day when the sun is shining. In fact, it can be used 24 hours a day with this type of technology. The more common type of technology, which is on the right side of that previous photograph, is solar photovoltaics, is where you generate electricity with photovoltaics. They're either in power plants or on your rooftop. So it's rooftop solar.
Is there any place in the United States where solar power is actually pumped into the main power grid?
Oh yeah, in many, or almost most states, you have some solar power that goes into the grid either from rooftops or from power plants. In the southwest US, where you have the greatest solar resources, you have the greatest abundance of solar that's already installed. California has a huge amount of solar already installed, both on rooftops and in power plants that's already generating lots of electricity for the state.
Now, is this electricity, how does it compare economically with electricity generated by oil or gas? Would people have to pay more for this kind of energy?
Well, this is an interesting question. So wind energy is actually, if you're in a reasonably fast wind location, is the least expensive form of all electricity, whereas solar is more expensive right now than your average electricity, but the price is coming down. So just to give you an idea of why wind is so inexpensive, if you take the 5 states in the US that have the highest fraction of their electricity from wind, which are Iowa, South Dakota, North Dakota, Minnesota, and Wyoming. In fact, Iowa and South Dakota generated 25% of all their electricity from wind last year. The price of electricity in those states between 2003 and 2011 went up only 2 cents per kilowatt hour. All the other states, the electricity price went up 3.6 cents a kilowatt hour. In Hawaii, it went up 17 cents a kilowatt hour in that same period.
Is that because the price of gas fluctuates?
It's because the price of fossil fuels continuously goes up because you have to mine them, transport them, and refine them. And so there's all these costs that go into fossil fuel, the fuel price. Whereas solar and wind, there's zero fuel cost. All the cost is in the capital cost, which is installing the turbines or the solar panels. So once you've installed them, you have a constant price after that. Whereas the other fuels, once you've installed them, the other fuels have a lower, what's called capital price cost, but their fuel cost is higher. So they gradually go up over time. So what we expect is eventually all the renewable energy sources, the prices are going to be less than the fossil fuel sources. It's just a matter of when. And right now, wind is actually, in fast wind locations and modest wind locations, is less expensive than natural gas or coal, except for old coal, which is grandfathered in under the Clean Air Act amendments, where they don't have to put in pollution regulations.
Well, let's talk about wind a little bit. I think we have a slide showing the pattern of wind. Can we see that slide? All right, so wind speeds at 100 meters altitude.
Yeah, that's 100 meters above the ground level.
And which is the highest winds, the blues or the reds?
Well, the reds are the highest winds here. And what this indicates, in North America, the fastest winds are in the Great Plains and offshore, the East Coast and the West Coast.
Because there's no mountains obstructing them?
Yeah, when you have friction such as buildings or mountains, but even over mountains, the wind tends to converge and you can get fast winds at the top of the mountains, but generally you get a lot of roughness, so that slows down the winds. But this slide is interesting because it shows that there's enough wind to power the world around 7 times over for all purposes with wind. But you really want to combine wind and solar together because the power demand is really what you need to match. And the sun doesn't always shine, the wind doesn't always blow. But wind and solar are very complementary in nature, such that when the wind is not blowing during the day, the sun is usually shining and vice versa. So if you combine wind and solar in optimal proportions and you use something else like hydroelectric to fill in the gaps, you can actually match the power demand extremely well. And so this quells one of the biggest issues with renewable energy, is that it's what's called intermittent. And the grid operators always worry, well, you won't have enough wind on a certain day, you won't have enough solar, so therefore the grid might not be reliable, you might have blackouts. But in fact, it's been shown in several studies now that this isn't the case if you optimize the grid properly.
Now, I think we have a slide that shows both wind and also water and wind, how wind creates waves that we can get electricity from. Maybe we can take a look at that slide.
Yeah.
Okay, so I can see the windmills on the left. Now, what are those objects on the right? How did they generate electricity?
Well, on the right, those are wave devices, and they take advantage of the up and down motion of the waves to generate electricity. And there's a cable that goes from each device underwater to the shore that sends the electricity to the shore. And so wave power, well, you need wind to drive waves, but the waves are actually more steady than the wind, or the wind might be more intermittent. The waves are kind of more steady.
Well, we have tides all the time anyway, whether there are winds or not.
Yeah, well, you also have tides too, which are a little bit different than the waves we're talking about. So there's another device that you can actually take advantage of the motion of the tides to get energy as well. But the wave power is driven primarily by the winds. And I think there's another slide here that shows that by combining wind and wave power, you can actually provide either smoother output.
Right, so there it is. So yeah. At times when one source isn't generating anything, the other one might be, and vice versa.
Right, that if you combine wind power plus wave power, even at the same location, you can get a smoother overall profile of the output, which makes it a little bit easier to match the power demand on the grid.
Now, are these technologies really ready for prime time, really ready to scale up to replace fossil fuels, or do we still need a few more scientific breakthroughs?
Well, wind and solar, we don't need scientific breakthroughs. I mean, last year, in fact, 50% of all the new electric power in the United States was wind plus solar. And in Europe, it was over 60%. So these are ready for prime time. However, we need to go to 99% each year, even 100% wind and solar if we want to convert everything to clean electricity. Because if we have half of all new power being coal or gas each year, which is what we currently have, then that means these plants are going to be there for 30 years or so, and we're not going to solve the climate and pollution problems that we need to.
Now, can we use the existing infrastructure with these new power sources? So in other words, instead of a coal-fired plant, you have a solar plant, but it's still using the same wires to deliver the electricity to somebody's house.
Yeah, so probably the biggest barrier is transmission. We can use substantially the current transmission system if we put in lots of wind and solar, but we will need the wind often is in places that's far away, like in the Great Plains, but it could be close, like offshore, especially the East Coast, which is the biggest untapped resource of wind in the world, basically, which is not far from load centers. And solar is usually in desert regions or in southern latitudes, and you might need to increase some of the local transmission. There are transmission lines already crisscrossing the US, for example, that can be utilized, and you might just have to increase the size of the lines rather than create new pathways for the most part.
Is it possible for individual residences or buildings to generate all of their own electricity through wind and solar without having to be connected to a grid at all?
Yeah, so this is the idea of distributed energy, that you have solar panels on everybody's roof. In some places where you have good backyard wind, you can have your own small turbines. And so this is an idea where you can be disconnected from the grid and generate your own electricity. But there is some advantage to being connected to the grid, because if you're not connected to the grid, then you do definitely have to have some kind of storage, either batteries or some other type of storage, so that when the wind's not blowing, the sun's not shining, and you want to use electricity, then it's available, which you can do. But the cost of batteries right now is higher than your typical grid storage.
What are the main obstacles to implementing clean energy more rapidly?
Well, we think on a global scale and even on a countrywide scale, there's no technical or economic barrier to converting 100% to renewable clean energy for all purposes, not only in electricity, transportation, but also heating and cooling and industrial processes. The biggest barrier is really, or barriers are social and political. It's very difficult to convince people to make changes and policymakers to make changes. There are many vested interests, so they're going to fight, because a lot of companies in the fossil fuel industries in particular, and in the vehicle industries where they produce combustion vehicles, they have a lot of vested interests, and they're going to fight because they make money on the current system. And so this is the biggest barrier to conversion. It's not a technical or economic limitation to the conversion. As we've seen, states that have a lot of wind, their price of electricity goes up less than states that don't have so much wind.
Well, if we have free enterprise and renewable energy can compete successfully economically with fossil fuels, wouldn't they just naturally take over?
It will take over, but it'll take, if we just let the current system, which has certain policies in place that tend to favor fossil fuels through subsidies in particular, even though wind and solar do get subsidies, the total integrated subsidies of fossil fuels plus the current subsidies is much greater than those from the wind and solar. And so there's no incentive for natural gas, for example, to go out of business. So they're going to keep running. As I said, we need to go to 100% each year new energy. And right now we're at 50% in the US, but if you go outside the US or outside of Europe, you still have a lot of fossil fuels being developed every year. And to get to 100%, you really need aggressive policies put in place. You have to get rid of the subsidies, all the subsidies to the fossil fuels. Try to put in policies, either renewable portfolio standards, but there are just literally dozens of possible policies to try to promote wind, solar, some geothermal, some tidal wave, and a little bit of hydroelectricity. But hydroelectric, we're not going to increase very much, if at all. It's just really utilizing better the existing hydroelectricity.
Well, aren't there some government incentives now for using renewable energy? So if you put on solar panels on your house, you get all kinds of tax breaks?
Oh, there are. So there are subsidies right now to solar and wind, but at the same time, there are subsidies to the fossil fuel industry. Just to give an example, it was around 2000, these are maybe a little older numbers, but 2003 to 2008, the fossil fuel industry in the US received about $70 or $75 billion in subsidies, whereas wind plus solar received about $5 billion. So there are subsidies to wind and solar, but there are also subsidies to these fossil fuels through tax breaks, through direct payments, and through health costs, even like the black lung program that coal gets. They've been paying out billions of dollars since the early 1970s.
Is it possible that the big fossil fuel companies would become leaders in moving over into renewable fuels? So instead of thinking of themselves as oil companies, if they thought of themselves as energy companies trying to sell energy however it's manufactured?
They can, but they've done a poor job so far. It's more likely the scenario would be something like in transportation. You could see it with Tesla Motors. They're a brand new company. They didn't start from an existing big three auto company. They started on their own. They developed a great new technology that works. That's great cars that can go now over 300 miles on a single charge, can be charged in an hour, and they even might have battery swapping where you can actually swap it within 60 seconds, accelerate really well. So it'll probably be the model, maybe, that companies who just develop a focus on clean renewable energies will be the ones that come out ahead, and the existing oil companies and the existing automobile companies, they're going to still persist and they'll gradually change, but probably not so fast as emerging companies that just are focused on clean energy.
Well, I saw that General Motors is now going to launch an all-electric car to compete with Tesla. So Tesla is creating the market, and the big automakers are saying, hey, there's a new market here. We don't want to be left out of this.
Yeah, that's great. I mean, the more the better, because that'll drive the prices down, that'll more competition, that'll allow more variability in terms, or improve the technology faster, and gain wider acceptance among the public. So that's great if they do that.
Would you say that nuclear energy is basically dead at this point as a future energy source?
Yeah, well, it's not growing. I mean, there were 440 nuclear reactors in the world 2 years ago, and after Fukushima, that dropped down significantly to around 400. In the US, we're not increasing, we're actually dropping out a couple of reactors. And you know, nuclear it's so costly, and it takes so long to put up a single nuclear reactor, basically between 11 and 19 years between planning and operation of a reactor versus 2 to 5 years for solar or wind, that while you're waiting around for one nuclear power plant, you know, the Arctic ice will be melted, because the Arctic ice is expected to melt entirely in the summers within 10 to 30 years. So we really can't afford to wait around for nuclear. Nuclear still puts out between 9 and 25 times more carbon dioxide emissions and air pollution than wind energy per unit electricity generated. So it's not a totally clean carbon source. It's cleaner than other fossil fuels, but not as clean as wind or solar. Plus, it has the radioactive waste issue. It also has the issues of leakage through meltdowns. 1.5% of all nuclear reactors ever built to date have melted down to some degree.
A slight accident could take away your entire investment very easily.
Right, and also there's the nuclear weapons proliferation issue, that 5 countries of the world have secretly developed weapons under the guise of civilian nuclear energy programs. So it's probably not going to grow very much, if at all, and it's not something that we would think is a good technology for the future, because wind and solar do not have catastrophic risks problems like nuclear does.
Where is most of the research in solar energy? Is there research being done on ways to make it more efficient? I mean, are you limited, like you just can't get more solar energy than falls on a certain space?
Well, solar does not, I mean, so I'll give you an example of how much space it takes for solar. You know, if you want to power the entire US vehicle fleet, starting with wind, you would need about 73,000 to 140,000 5-megawatt wind turbines. And that would take up about 1/3 the size of South Dakota, which is, just to put in comparison, is about 1/30th the land area needed to do the same thing with corn ethanol. So you need 30 times, 1/30th the land area for wind turbines to power the US vehicle fleet than corn ethanol. And that's just the spacing area, and you can use that space for many purposes, like agriculture, open space. But solar is about 1/3 of that. So solar is it takes about 1/90th the area to run the whole US vehicle fleet than corn ethanol does. Because photosynthesis for biofuels is only 1% efficient. And whereas solar, it has a higher efficiency in terms of converting sunlight into electric power in this case. And this is, by the way, for solar energy or wind energy running battery electric vehicles versus ethanol for combustion vehicles. And so it doesn't take up a lot of space, but there are energy efficiency improvements that are continuous. There are a lot of people researching and trying to make better solar panels. And there's also a growth of solar, and that's driving the price down. And wind is also being made more efficient, although there's not a huge amount you can do to improve the efficiency of wind energy.
I thought there were some problems with wind turbines because birds fly into them and damage them. And
well, the birds don't damage the turbines, but there are bird kills from wind turbines. But to put it in perspective, the bird kills from wind turbines are about 1/10 the bird kills of either natural gas or coal per unit electricity generated, because natural gas and coal kill birds through land degradation during mining process, due to the air pollution from them, and due to actual buildings that they run into. And so it's actually a red herring to say that wind is bad. It does kill birds, but it's 1/10 of those of natural gas or coal.
Is there any way to capture really big wind events? So, for example, if you could capture the power in a tornado or a hurricane, that would be a lot of power that could last a long time.
Yeah, we've studied the impacts of wind turbines on hurricanes, and we found that if you have large arrays of offshore wind, you can actually not only generate electric power during the year when the hurricane is not even present, thereby paying for the wind turbines. But when a hurricane does come along, you can actually dampen a hurricane. You need a lot of them, but you can actually reduce the storm surge, which causes most of the damage, by up to 70%, we found for a simulation of Hurricane Katrina. And the more standard scenarios might be 50%, which would be a huge reduction of the damage. And so the alternative is, well, you can put up seawalls, which in the case of New York, after Hurricane Sandy recently, the governor or the mayor of New York City proposed seawalls off of the coast of New York City. And this would cost a huge amount, and it would not generate any electricity. So it has one purpose, and it might reduce damage. But we found that you can do the same. You can reduce the damage in a similar way with the offshore wind turbines while generating electricity year-round, thereby paying for the turbines. And so you serve multiple purposes with offshore wind turbines.
Now, in recent years, the price of gas has gone down quite a bit because of fracking, this horizontal drilling where you break up rocks and release gas in it. But that seems to have a lot of potential and real environmental problems. Do you think that the fact that it's so cheap will let us keep using fracking even though it does have problems compared to these natural sources?
Yeah, I mean, certainly the low price of natural gas due to fracking is pushing its use more. But this is why policies need to be put in place to address this. I mean, the environmental side effects of fracking are not only groundwater contamination, but also air pollution, but methane release, which methane is one of the main leading causes of global warming, but it also is one of the main leading causes of Arctic sea ice loss. And so it's a mistake to think that natural gas is what's called a bridge fuel because it actually enhances global warming compared to wind and solar significantly. It's on the order of 60 to 70 times more global warming emissions per kilowatt hour generated of electricity from gas versus wind.
And we're going to have to wrap on that note because we are out of time, unfortunately. I'd like to thank my guest, Mark Jacobson, atmospheric scientist from Stanford University. And thank you for watching. Visit our website, www.futuretalk.net. For Future Talk, I'm Marty Wasserman. We'll see you next time.